Hello, so for today I will be talking all about trusses. We all know what trusses look like, but how should we define a truss? So in the textbook glossary, it is defined as a triangulated arrangement of structural members that reduces non-axial external forces to a set of axial forces in its members. So in other words, it really relies on the triangulation of the vertical and diagonal elements to really support a structure. I will continue in a question and answer format to really go in detail about what you should know about trusses. First off, what are the advantages of trusses? Well, there's a lot of advantages. It's great that when you're using trusses, it's using less material than a comparable frame like a conventional rafter and ceiling joist. You can also span the entire width of the building in most applications. So you could span a lot more with less material with trusses. And another advantage is that it allows the designer or architect to really have greater freedom in locating the interior partitions of the building. But along with these advantages, there are also disadvantages of using trusses. Well, the first one is that it makes the attic space unusable. When you're using trusses, it just takes up so much space for the ceiling. And it also restricts the designer to having a flat ceiling throughout the building, which can be boring, but it works. The good thing about trusses is that it uses triangles, which is a really stable shape. Now, what makes up a truss? Based on the images, you have nodes, which also have gusset plates to keep it in place. You have members that are in tension and in compression. The typical truss support is usually located at the nodes where the gusset plates are located. Gusset plates look like this with metal and sharp nails with it. Each node is connected to either a bottom chord or top chord along with the diagonal elements of the web. Next question. Why do trusses have notch at the ends? Well, they have these notches at the end so that the studs of the building, whether it's 2x6 or 2x4s, can really connect and run perpendicular to it, just locked together with the truss. Where are the areas of tension and compression located in the truss? Where tension is located, it's at the vertical elements, while compression is located at the diagonal elements. This explains why trusses can use two different materials like steel and wood, because some materials work better in tension versus compression. For example, slender steel rods cannot resist compression, so then that's where you would use wood. This can be seen in an open web truss where it's combining wood and steel to provide a strong and lightweight truss. It really allows for easy duct penetrations, and that usually they can span up to 14 to 64 inches in depth. These are the top few takeaways that you should know about trusses. It spans wide with less material. It's slender and therefore uses less material. 4 trusses can span up to 70 feet, which is great. You can also have no squeaking due to its structural integrity. Each member should be in pure tension or pure compression. Tension occurs vertically, while compression occurs diagonally. A great example of a building that really uses trusses is this warehouse located in LA that's designed by Durst Builders. They're using a bowstring truss to keep that vintage look. And then notice at the bottom chord and the top chords, there are nodes with each of their own having a gusset plate, which provide the structural stability for the roof above.